All right, let's open up the Ultimate Math Survival Guide. Now, forget about those dusty old theorems you had to memorize for a test. We're talking about powerful, practical tools that actually help us solve real-world problems. You ready? Let's dive in. Okay, first question, and it's a big one. It's something every single business on the planet is trying to figure out. How do they find that perfect sweet spot? Between making too little and making way too much. How do they know for sure that they're squeezing out every last dollar of profit? Well, it turns out there's a golden rule for this. A simple core principle that just cuts right through all the noise and gives us a clear target to aim for. And here it is. MR equals MC. That stands for marginal revenue equals marginal cost. Think of it this way. You should keep making one more item as long as the money you get for it, that's your marginal revenue, is more than what it costs you to make it, your marginal cost. The second it costs more to make that item than you earn from it, you stop. Right there. That's the peak. That's max profit. But how do you actually find those marginal values? You can't just eyeball it. To pinpoint that exact moment, we've got to pull a very specific, and I mean incredibly powerful tool out of our survival kit. And that tool comes from the world of calculus. And this tool is all about understanding the rate of change. To be specific, we need to talk about something called the derivative. Now, don't let the fancy name scare you off. A derivative is basically just a high-precision slope finder. So if you imagine your company's profit as this big curve on a graph, the derivative tells you the exact slope, the exact rate of change, at any single point along that curve. It's like a speedometer for your profit. And finding this slope isn't some kind of magic trick. It just follows a clear set of rules. For example, what you see here is the power rule. It's a simple little shortcut that tells us exactly what to do with exponents. It's one of a few basic rules that let us find the derivative for most functions almost instantly. And hey, when things get a little more complicated, the toolkit just gets bigger. You've got rules for when functions are multiplied or divided or even nested inside each other. The point isn't to memorize all of these right now, but just to know that there's a system, a process, for pretty much any situation you can throw at it. Okay, so here's the crucial part. This is where it all clicks. What happens at the very, very top of that profit curve? Just for a split second, the slope is perfectly flat, right? It's not going up anymore, and it hasn't started going down yet. And a flat slope means the rate of change, our derivative, is 0. And that's it. That's the secret. Find where the derivative equals 0, and you found the top of the mountain. All right, enough theory. We've got the rule, we've got the tool. It's time to put this thing into action and solve our original problem. So here are our company's functions for total revenue and total cost. First, we use our derivative tool on each of them to find the marginal values. Then we apply our golden rule. We set them equal to each other. A little bit of algebra later, and boom! We solve for Q, and we find that the absolute best production level is exactly 4 units. And what's the actual profit at that level? Well, we just plug our magic number, 4, back into our main profit equation, which is just revenue minus cost. And the result? A maximum possible profit of 22. We did it. We found the peak. That is the power of optimization. Okay, so that's great for one company, but what if your problem is bigger? Like way, way bigger? What if you need to solve for dozens of businesses, or maybe even an entire national economy? Yeah, this is a whole different level of complexity. We're not just optimizing a single curve anymore. We are now modeling a massive, tangled, interconnected system. Just think about it for a second. The steel industry needs coal. The car industry needs steel. The coal industry needs heavy machinery. And around it goes. It's this giant web of dependencies. You can't use one simple equation for that. Nope, you need a totally different tool from the survival kit. And for a job this big, we turn to a different branch of math, linear algebra, and specifically, the incredible power of matrices. What you're looking at is the Leon Teef input-output model, which goes all the way back to 1951. It uses a matrix, that grid of numbers, to perfectly map out how much each industry needs from every other industry. That formula looks pretty intense, I know, but it's really just a super organized way to solve that entire web of dependencies all at once, giving us a complete snapshot of the economy. And just like our derivative tool, this model has its own set of rules to make sure it gives us sensible answers. These are called the Hawkins-Simon conditions, and they're basically a reality check. They run a test to confirm that the economy we've described is actually viable, that it can produce more than it consumes, which is kind of important. So let's zoom out. What have we really seen today? We've seen that math isn't just one thing. It's a whole kit of different tools. We've got calculus, which is perfect for finding that one optimal solution, the peak of the mountain. And then we have linear algebra, which is perfect for modeling huge, complex systems. But both tools and our survival kit are driving us toward the same goal, making smarter, better, data-driven decisions. And that, right there, is the most important takeaway. It's about shifting how you see it. Math isn't just some boring class you have to pass. It's a collection of elegant, powerful tools for making sense of a very, very complex world. So the next time you're up against a complex problem, big or small, just remember what's in your survival kit. You've got the tools, you've got the rules, you're ready.